Okay, here's a couple good questions that deal with concentration and how many moles of stuff are in a solution, etc. The first question deals with number of ions, and you have to be careful with that one. So it says, which of the following contains the greatest number of ions in solution? To figure out the greatest number of ions in solution, you first have to dissociate the equations. So let's do that with each one of them. So sodium fluoride is NaF, and if you put that, and that's a solid, if you put that in water, it'll become sodium ions, and it'll come fluoride ions. So if I have, now I don't know how many moles of this stuff I have yet, so let's go over and figure that out. But the ratio is 1 to 1 to 1. So if I have 1 mole of this, I'm going to have 1 mole of that and 1 mole of that. Altogether, I'm going to have 2 moles of ions, and that's what they're looking for, greatest number of ions. So here I'm going to have 2 moles if I had 1 mole to start with, but I got to figure that out. So let's do that. I have concentration is equal to moles over volume. I want to solve for moles. So I have to move the volume to the other side and multiply it. So moles are equal to C times V. The C is 2 molar, so 2.00 moles per liter, times the volume is 3 liters, 3.0 liters. Liters cancel, so that gives me 6.00, or 6.0. No, thinking too much about sig figs right now, but that gives me 6 moles. So the reaction says if I have 1 mole, I get 1 of these and 1 of these. So by logic, if I have 6 moles of this, then I'm going to get 6 moles of this and 6 moles of this. Because if you start with 6, this one's going to produce 6 moles, this will 6 moles. So altogether, and typically we don't do this when we're doing calculations, but altogether if you add the 6 into the 6, that comes up to 12. So that first one you get 12 moles of ions in solution. Let me move down and do the other 2 down below. Okay, so let's do this one in blue. This one. So let's write our formula or our equation. Sodium carbonate. So sodium and carbonate. Carbonate's a 2 plus and 2 minus. Sodium's a 1 plus, so I need 2 of these. Okay, so there's sodium carbonate, and it's a solid. If I dump that in solution, it'll give me sodium ions, and it'll give me carbonate ions. And since there's a 2 there, I need to put it. So it'll give me 2 sodiums and 1 carbonate. So 1 sodium carbonate mole is going to give me 2 moles of sodium ions and 1 mole of carbonate ions. Okay, feeling good there. So now let's figure out how many moles I have. So concentration is moles over volume. So moles are equal to C times V. So the concentration of this one is 4 molar times the volume is 1 liter. So liters cancel. So altogether I have 4.00 moles of this one. So let me put that right up here. So there's 4, that's what I'm starting with. That's how much they gave me. And so in the end, I'm going to have double that, so there'll be 8 moles of this stuff and 1 mole, oh no, I have to times it by 4. 1 times 4 is 4. So 4 moles of this stuff. So altogether, that's giving me 12 moles of that one too. Well, those are the same. Okay, next one. Let's do this one in green. So this one is in green. I don't know if that's the right answer or not, but I'm just making it's green. Potassium chloride. So potassium chloride is a solid. Dump that in water, and you get potassium ions, and you'll get chloride ions. I probably should have aqueous beside all these just to make it perfect. So if I have one of these, it gives me one of those and one of those. So same formula, right? N is equal to C times V. Concentration is 2.5 mole per liter. The volume is 2. So that would give me 5 moles. Liters cancel. 5.00 moles. So if I have 5 of these, I wind up with 5 of those and 5 of those. So altogether, that's only 10. Okay, that's not going to be the answer. Magnesium chloride, let's do that one. I was just going to stop and say, you go ahead and finish it, but go ahead and finish it and then come back and check the rest of the video and see if I get things right. Okay, time to change color. I like that olive today in class. We'll use that. So magnesium chloride. So magnesium and chlorine. Magnesium is a 2+, so I need 2 of those to balance. And if that's a solid, if I dump that in water, I'll get magnesium 2+ ions, and I'll get chloride ions. Let's make them aqueous and aqueous. And to balance, I need 2 there. So if I have one of these, it'll give me 1 of those and 2 of those. So let's see how much I have then. So N is equal to C times V, concentration 2 moles per liter, times the volume is 2 liters. Oh, 2.0 liters. Multiply, that gives me 4. So 4 moles. So if I start with 4, I'm going to have 4 of these, and 2 times 4, that'll be 8 of those. Altogether, that's 12. Oh, gee, well, it better be the last one. Because I've got 2 ties at 12 and a 10. 2 or 3 ties at 12. Okay, let's do ammonium phosphate. Move up a little bit. Ammonium phosphate. Different color. Orange. Okay, ammonium phosphate. So ammonium is a 1+, phosphate's a 3-. So I need 3 of these to react with 1 of those. Okay, and if that's a solid, it'll go into ammonium ions, 3 of them, and they're positive ions, and 1 mole of phosphate ions. Okay, that 3 might be the difference maker. Okay, so 1 of these produces 3 of those and 1 of those. So let's see how many I have to start with. So N is equal to C times V, concentration 2 molar, times the volume is 2 liters. Yeah, that's right. 2 liters, you multiply, that gives you 4. 4.0 moles. Okay, so if I start with 1, I get 3 and 1, but what if I start with 4 moles of that? Then this is going to be 12, and this is going to be 4. So altogether, that's going to be 16. That's the most number of moles of ions right there. That's a long question to do. And yeah, it's nice that the correct answer is the last one, so you have to do all of them. Good one. Okay, here's another question that deals with mass percent. So nitric acid solution that is 40% nitric acid by mass contains what? Okay, well let's look at our formula. Mass percent is equal to solute mass divided by total mass times 100. Okay, so it says 40%, so that's 40%. So 40% is equal to solute and total. It's not giving us any of those numbers. And really, these here would just be suggestions on how much it could contain. It could contain tons of other different numbers. They just have to be in the same proportion. In other words, they'd have to have, if this is an example, 40%, I'd have to have 40 grams of solute over 100 grams of total solution. Okay, so that is if the total solution is 100 grams. But like I say, you could use lots of different ratios. Like if it's 40%, you could use 80 over here and 200. Like if you go 80 divided by 200, that still gives you 40%. So you don't have to use the 40/100, but it looks like that's what they're doing. Okay, so now that's total solution. Involved with that too, I don't know if they need that, but if this is 40 grams of solute and 100 grams of total solution, it means if you take the difference there, you'd have to have 60 grams of solvent. So if you have 60 grams of water and 40 grams of nitric acid, put them together, that's going to give you your 40% solution. So let's see which one of those are it. 40 grams of that and that. That's tempting, eh? But this bottom number is your total solution, so it's not just water. That'd give you 140 altogether. That's not it. None of these, don't know about that yet. 40 grams of nitric acid, yeah, that's the one I'm going with. 40 and 40, no. 40 moles, no, we don't know how many moles. Has to be that one right there. So 40 grams of nitric acid, add it to 60 grams of water, you'll get 100 grams total of solution, 40 of which will be the nitric acid, so it gives you 40%. All right, hopefully that helps you with those couple questions.